today's session. Today I will be today we will study variables, operators and expressions. So let's start. So these are the topics which we are going to cover today. First is variables, then we will study about constant, about data types, types of data types, data type modifiers, type conversion. We will also study operators in C++, see all types of operators with its precedence and scope of variable and expressions in C++. So let's start with variable. So variables in C++. So what is a variable? A variable is a name given to a memory location to store data. In memory, when you store some data, you have to store it in a variable. So what is a variable? A variable can be imagined as a container in which some data or item is stored. Like in everyone's home, there are some containers of salt, sugar, tea. So a variable is like that, a container in which some ingredients are stored. So in C++ the ingredients are data, and in normal containers we store ingredients. So in C++ the ingredients are compared with data. So what is a variable? A variable is a name which is given to a memory location to store data, and that memory location holds some address. So what is the syntax of variable? So a syntax of variable is, it is started with a data type such as integer, float, double, and then a variable name. For example, if you want to store age 25, then we will write int age and then we will store 25. So what happens with the 25? The 25 gets stored in the memory with the name of the location called age, and there can be any address such as 1001, 1002 where the age 25 is present. So to write some variables in C++, we have some rules. So first rule is that all variable name must start with an underscore or a letter, but should not start with any digit. And number 2, it should be no reserved word keyword for C++. In C++ there are many reserved words which are understood by the compiler, and that should not be used as name of the variable. If it is used, then the compiler will get confused and will give an error. So it should be avoided. Then the name of the variable should not contain any special character such as asterisk, ampersand. That should not be there in the name of the variable. The name of the variable should be meaningful and should not be a reserved word. You can write any name of the variable. So in C++ it is a case sensitive language. So uppercase letter and lowercase letter are considered different. So take this note that C++ is a case sensitive language. Uppercase and lowercase letters are considered different. So let's now move on. Now what is a keyword? You have already known now that keyword are some special reserved words which are understood by the compiler, and they have a predefined meaning and usage. For example, const keyword, static, auto, typedef, using, namespace, return, size of, enum, and many more. If else, switch case, default, for while, int, float, etc. So now what are constants in C++? So during programming you will sometimes want to keep some values which would be fixed, such as the value of pi. If you want to calculate radius in a program, then you will have to take a value of pi. But if you take variables data can be changed in a program, but the value of the pi is always constant. It's always 3.14 something. Then you have to always keep it constant. So for that problem we use constant. So what is a constant? A constant is a fixed value that can't be altered or change during program execution. We use constant for values that do not change. Example, mathematical constants, configuration value, such as value of pi, which is always 3.14. So there are two ways to define a constant. First, you can use a const keyword. What is a const keyword? A const keyword makes the compiler understand that the value which is given by the user is constant and it should not be changed in a program. For example, you can write const float pi equal to 3.14. We are assigning value of pi as constant, which always has 3.14 value. So the next step we can define a constant is by using hash define in the preprocessor directive. So in preprocessor directive, where we had hash include IOStream, there we can define the hash define pi 3.14. By writing this, you will define that the value of pi is 3.14 throughout the program. So there are generally two ways. First, using const keyword and then using hash define in preprocessor directive. So now, what are data types in C++? You have already learned that when we write a variable, we have to first define data type. So what is a data type? A data type defines the type of data that is stored in a variable or in a constant. It is used in a programming language to make the compiler understand that what type of data a variable can hold. You can't give any values to a variable. You can't give any values to a variable, but the values given to a variable are always fixed, such as int for integer, float for point values, char for character, bool for boolean, double for double values. So there are three types of data types. First is primitive data types, which have all the primitive data types such as integer, float, char, bool, double. Then is derived data types. It is derived from the primitive data type such as arrays, which is a collection of numbers. Then is pointers, which stores the value of another variable. Pointers store the value, store the memory address as values. Then is functions, which do some function in a program. Then is references. Then is user defined data types. So user defined data types are not primitive data types or derived data types. They are defined by the user, such as structures, which is written with the keyword struct. Then unions. Then classes. Each type determines the kind of data and size of memory the variables will occupy. So each data type, whether it is primitive data type, derived data type or user defined data types, it determines what kind of data or size of memory the variables will occupy. So now, basic built-in data types. We already know that there are three basic types of data types. First is built-in, then is derived, and then is user defined. So now, first we will study about built-in data types. So built-in data types are built in the programming language. First is int. Int stores integer values. It has a memory space of 4 bytes, but it depends on the machine. So in some machines, the value of the integer value is 2 bytes, but in a normal scenario, we take it as 4 bytes. So in some machines, there is always 4 bytes, but it depends on the type of compiler or type of computer you are using. So int has integer values and stores 4 bytes. Example is int x equal to 5. Then is float. So float is a single precision floating point value. So float contains decimal values, and integer does not contain decimal values. It only contains minus values and positive values. There is float. Float contains floating point numbers. It also has memory size of 4 bytes, but it always depends on the computer. So example is float pi is equal to 3.14. So in float you can also write 3.14 f at the last. If you do not write the f, then the compiler will take it as a double number. Then is char. Char stores single character. It has 1 byte. Example character c equal to a. In variable c, the character a is stored. Then is bool. Bool has boolean type. So what is a boolean? Boolean contains true or false values. True has 1 value and false has 0. So boolean type has only 1 byte because it only stores 0 or 1. For example, bool is valid true. Before C++, in C there was not any boolean type, but in C++ you have boolean types of data. So now other data types. So these data types are not important for now, but we will see this in other video lectures. So first is derived data types. They are created from fundamental data types such as arrays, pointers, functions and references. Then is user defined data type. It extends built-in data types for complex data such as structures, unions and enums. By this you can also create data structures. So now data type modifiers. So in programming, some situations come when you have to increase the size of the data types. Then you can use these data type modifiers. It modifies the range and storage of the basic data types. First is signed. It is used with integer. So signed int. It can store negative as well as positive values. It can also store negative values as well as positive values. From the starting, integer is always signed. If you do not write signed in front of integer, then also it can store sign. It can store negative and positive both values. But by using signed, we make the compiler understand that we are wanting to store negative and positive values. There is unsigned. It is also used with integer. But when we write unsigned, it only stores the positive values. The range for the positive values only increases. The negative values are skipped. It only stores positive values and doubles the max range. Then is sort. It reduces the memory size. If we write sort int, then if the int has 4 bytes as its storage, then it gets reduced to 2. The sort keyword reduces the data type by 2. Then is long. Long increases the range. So long is used with integer, float or anything. There is also a data type called as double. It increases the range with double the value. For example, of unsigned is unsigned int x equal to 40,000. Then is long double y. It's 3.1415. This large number can be stored in this long double y. You can also write two data type modifiers along with a data type, such as long int. It increases size by 4 plus the value, 4 plus the size of long. So if you write long, then the integer gets much longer. So you can use these data type modifiers in the program. Then now type conversion and typecasting. So type conversion, typecasting. So type conversion, it is also called as type promotion. It is done by the compiler, and typecasting, it is manually done by the user. So why we need type conversion, typecasting? So we need typecasting because in programming sometimes you have to change the type of the variable to other type. For example, if you multiply two numbers, one is float number and other is integer number, when you multiply it, the number would be very long, so the integer can't store the value. So for that reasons it have to be promoted to another large data type which can store it. So a float is large and int, so the compiler will automatically promote the integer to float values so that the big number can be stored in float. And if it is not stored in float, then compiler can again promote it. There are some rules. If you multiply, add with integer and float, then always the compiler promotes the integer value to float. For example, if you keep an integer value as 10 and you put that 10 value in another variable called float, then the 10 will become 10.0. So it is called as implicit conversion. Why it's implicit? Because it is done by the compiler. In this, the smaller data type is converted into bigger data types. Then is explicit typecasting. It is a typecasting which is done by the user. The type conversion is done by the compiler and typecasting is done by the user. In explicit typecasting, it is explicit because it is done by the user. In this, the bigger data type is typecasted to smaller data type. The float is converted to integer and the integer is converted to character. This is called typecasting. And in type conversion, the integer converts to float, the float converts to double. So typecasting and type conversion is important for precise control and avoiding data loss. Yes, it's important because if you are writing a program and the data which is going to be the result is very long, so if the data type is not able to store it, then the remaining data will get lost. So for these reasons, typecasting and type conversion is important. It helps us to avoid data loss and gives precise control of the program. So now let's move ahead. So now scope of variable. So what is scope of variable? So in C++, there is a space for the variable where it can perform its operations. There are of two types of scope. First is local scope and global scope. The scope can be taken as a playground for the variable where the variable performs its operation. The range from where to where the variables can be accessed and its performance is taken out, how much it can work. There are two types, local scope and global scope. So what is local scope? The local scope defines the variable scope as local. If when we write variable inside some function blocks such as inside functions, inside main functions or user defined functions or inside any if else or loop functions, then the variables becomes local variable. It becomes local to the function and does not gets called by the other functions because it is written inside another function. So it will only get called inside that function only and is accessible only within those blocks in which the variables is defined. It will not get accessible to any other blocks. So a scope can be considered as a space where variables perform their operations. In local scope, variables perform their operations only inside the function blocks only. And second is global scope. In global scope, the variables can be called anywhere in a program. They are always declared outside functions. They can be declared they can be declared outside main method or in preprocessor directive. So they are global. So they are global in scope. They're always declare offset functions and they're accessible throughout the program. If you want to keep some variable data secret, then you can use local scope. But if the variable which you have declared has to be used everywhere in the program, then you should always make it global. So now let's learn about operators in C++. So in maths, you have always seen a plus b, a minus b. So our operation is performed between two values, such as 5 plus 1 equal to 6, 6 plus 1 equal to 7, or 6 minus 1, 5. So the plus, minus, multiply, divide, these are called as operators. And operators used to perform some operations on data. So in C++, you will perform some operations using these operators. First, arithmetic operators such as plus, minus, divide, modulus. Then relational operators. It is used to check the relation between two operands. That is logical operators. It is used to perform logical operations. Then assignment operators. It is used to assign values to variables. The values which are written in the right hand side are taken to the left hand side, which are the variables, and then stored in it. Then unary operators. Unary operators perform only one data. So the operators, arithmetic operator, relational operator, logical operator, and assignment operator take two operands to operate. But in unary operator, it takes only one operand to perform the operations. So now let's see one by one what are these. So first is arithmetic operator and relational operator. So you know arithmetic operators, you have seen in mathematics that we use addition, plus, minus for subtraction, multiplication. But in C++, the sign of multiplication is different, division is different, and there is also one extra operator known as modulus. So arithmetic operator used to perform arithmetic operations between two operands. First is addition, it is used to add two operands. Then is subtraction, it is used to subtract two operands. Then is multiplication, which is done by. So now arithmetic operators. Arithmetic operators such as addition, subtraction, multiplication, division, modulus, which finds remainder. Then are relational operators. It is used to find relation between two operands. It is used to test some conditions. First is equals. It checks equality. This equals, not equals, less than, greater than, less than, equal, greater than, equal are used with some conditions. It is used to check some conditions between two operands. That's why it is called relational operators. It is used to check a relation between two operands. First is equals. It is used to check equality. It is denoted by the symbol 2 equal to's. Then it's not equals. It is used to check not equal. It is denoted by not symbol, then equal. Then is less than, then is greater than, less than, equal, and greater than or equal. There are logical operators. It is used to perform logical operation between two operands. Logical in the sense it performs operation at bit level. First is logical AND operation. It performs logical AND operation. It is denoted by two ampersand signs. And then is logical OR operation. It is denoted by a pipe symbol. This symbol is called as pipe. It is called a logical OR operation. It performs logical OR. Logical OR checks that from both conditions, if one condition evaluates to true, then the result becomes true. And in AND it checks if both conditions are true, then only the resultant becomes true. And if one is false, then the result will become false. Then is not. It is called logical not operator. You can first you have seen that not equals to. So this not operator is called logical not operator. It is used in that previous relational operator. So what is a logical not operator? It reverts a given condition. So that's why it is called as not. If you give value true, then it will evaluate it to false. And if you give false, then it will evaluate it to true. So these are the logical operators. Then assignment operators. So assignment operators are used for assignment of values to variables. It works by taking the values from right and assigning it to left, which is the variable. The values are written at the right and the variables are written at the left with the equal sign, which is called an assignment operator. Operator. First is normal assignment operator written with equal sign. Then is C++ shorthand operators. So what are shorthand operators? Shorthand operators perform both the operation as well as assignment. First is plus equal to. In plus equal to, the values are added then assigned to a variable. Then is shorthand subtraction operator. This subtraction operator first subtracts the value and then assign it to a variable. Then is division operator. It is shorthand division operator. It first performs division, then assigns the values to a variable. So the assignment operator have also some use in C++. These assignment operators are used for assigning values. Then are unary operators. Unary operators perform operations on a single operand. First is increment operator, the decrement operator. Increment is written by plus and decrement written by minus. So it is used in two ways. So unary operator is used in two ways. First is pre, then is post. First is pre-increment. It has the rule that first use, then increase. So in pre-increment it is written plus x, which has the rule first use, then increase the value by 1. Then is x plus. It is called as post increment. Here x is a variable and plus are the unary operators. First is pre-increment, then is post increment. It has the rule first increase, then use. The decrement operator, it decrease the value by 1. First is minus x. It has the rule first use and then decrease by 1. Then is post decrement, which has x minus. So here also x is a variable. The post decrement has the rule first decrease by 1, then use the value. So these are called as unary operators. As it performs on a single operand, that's why it is called a unary operator. The other operator which I discussed before are binary operators because they perform operations on two operands. Let's move ahead. Here you can see the operator precedence. It defines the order of operators. So now operator precedence. Here you can see in this table the operator precedence is given. Operator precedence defines the order in which the operator are executed. In maths you have learnt about BODMAS rule. First bracket, then off, then multiply. It is a BODMAS rule. It also has operator precedence. So in C++, the BODMAS rule is only followed. It is called a operator precedence. So first in operator precedence, it is here given from higher precedence to lower precedence. The comma operator has the lowest precedence, and the parenthesis has the highest precedence. The operators begin their operation from the parenthesis. First brackets and then square brackets. Parenthesis, square brackets are first executed. Then second most are the postfix increment or decrement and prefix increment and decrement. the unary operators are performed. Then the multiplication, division, modulus operations are performed, and then addition, subtraction. Then if you come low, then you can see less than, equal to. After that are equal to, not equal to, then logical and, logical or, and conditional operator. So conditional operator gives value based on the condition. Based on the condition, we call it as a conditional operator. Then a simple assignment is equal, then a shorthand operator, and then the last precedence is comma operator. So by knowing the operator precedence, you can write programs in a more efficient way. So knowing our operator precedence is important. Then are expressions in C++. So a combination of variable constant operators to produce a value in the C++ program. So what are expressions? Expressions is a combination of variables, constant and operators to produce a value in a C++ program. So expression is evaluated based on its operator precedence. So there are three types of expression. First is arithmetic expression, which shows some arithmetic operation. Then a logical expression which has logical statements, and then a conditional which gives output based on the condition. First, in arithmetic you can see here a plus b multiplied by c, and logical if a is greater than b and c not equal to d. Then are conditional operators. If a is greater than b, then print a or print b. So these are three types of expressions in C++. So here is a sample program which is showing you the use of variables, constants and data types. So it is a value. So in this program we are calculating the area of a circle. So there is a constant float pi which is 3.14. Then we take radius as 5 and then we calculate the area as float. So by using this, the value of the integer will convert it into float values, setting pi into radius, because the formula for calculating a circle, for calculating circle's area is pi into r square. So here pi into radius, it gives us the area. So by writing this cout statement, we can print the value of area on the screen. Then we have to return 0. So it has all the things a program should have. First is preprocessor directive. It also has preprocessor directives. Then it also has namespace standard. Then it contains comment, and the operations are performed inside main function, and the main function returns some value. So these are the programs. You can try this program by yourself and practice this, all of which we are studying till now. So now let's look on some common mistakes which are done during programming and what are the best practices it should be taken. So the common mistakes are unnecessary variables. So if you want to perform some operations on variable, first you have to declare the variable and initialize its value first. If you are using variables that are not declared, so the compiler will throw an error that uninitialized variables have been used. Second mistake is incorrect data type assignment. Many times you user ignore the correct data type, so the compiler shows an error. You will always have to use correct data type during assignment. If you want to store integer, then you have to use data type int, and if you want to store float, then you have to write data type float. And the third mistake is division by 0. So you know that division by 0 is not possible. It will always give a error. So these are the three mistakes that should be avoided. Then let's see some best practices that should be done. So use constant for fixed values. Use const values for fixed values, the values which you want to keep fixed. Then choose appropriate data type. You will always have to choose appropriate data type based on what type of values, you want to store in a variable. Then comment your code for proper understanding. These are the best practices you can follow. You can follow commenting or not. But if you follow commenting, then it makes your code look more interesting and gives your code a proper meaning. So the fourth best practice is keep variable names meaningful. You should keep variables name meaningful. If you want to calculate interest, give the variable name as simple interest or not ISI, as it can give confusions to the user and may not be easily decipherable. So always keep the name of the variables meaningful. So now here are the homework problems which you can practice by yourself. So first is practice basic operators. You can write program to add two numbers, subtract two numbers, multiply two numbers, division two or three numbers. Remember, division by two or three numbers. Then second program is swap two variables using a third variable. Then convert temperature from Celsius to Fahrenheit. The formula for converting Celsius to Fahrenheit is Celsius into 9.5 plus 32. This is the formula. You can use this formula to convert Celsius to Fahrenheit. Write a program to find the area of a rectangle and revise all the basic concepts of variables, operators and expressions. Now we have reached the end of this session. So what we have learned, let's summarize. First, variables and constants store data. Variable store data which can be changed in a program, and constant store data which can't be altered or changed during a program. Second is data types define the nature of data. The nature of data which you want to store in variables, it is defined by data types. Then operators manipulate data and build expressions. Operator used to manipulate data and perform some operations and are used to build expressions. Always be cautious with typecasting and operator precedence. Fifth is understanding of scope to avoid bugs and side effects. Understand the scope which avoids bugs and also avoids side effects during a program. So this is all for today. Thank you. Thank you. So in our next session we would be study more about this C++ program. Thank you for today. See you in our next session. For that, thank you. So for more such videos, subscribe to my channel and also like and share this video. And if you have some doubts regarding this session, then you can comment below with your problems or any suggestions if you want. Thank you.